So the topic that we're going to be talking about is the chemistry of change and the role of advanced bentonite activation and how green sand foundries can benefit with this. And before I go deeper into the topic, I would like to briefly tell you about our company. We are now a material science and technology company, and we have engineered revolutionary new materials and technology for foundries. Well, my dream is that one day foundries should work at zero rejection. It's a tall claim, but I think that's what we would like to work towards. And our vision is to create ultimate value. And we want to do this by empowering foundries across the world to produce better castings at a lesser cost while being environmentally friendly. And one of the biggest core values that we hold very close to our heart is science based innovation and not imitation. So, to give you a brief background about how this all started, this company was actually started in 1990 by my late father, H.S. Gurunath. He, with the support of his very good friends, Mr. Ramanan and Mr. Vasudevan of Chennai chapter, they started in a small way where they manufactured refractory coatings for foundries, and that's why the name Refcoat came into being. And then they slowly diversified into supplying colder substitute for foundries. And at that time, I was in the US, I was doing my research there. And whenever I used to talk to my father, he always had a question to me. So he said, I supply the exact same product to two different foundries. And in one foundry, it's working very well. In the other foundry, they're kicking me out. Why? Why is it that the product performs differently in different foundries? And that was his question to me. And at that time, I had absolutely no idea about foundries. I'd never set foot in the foundry before that. And with my limited knowledge and boasting that I was doing my master's in research, I said, if it is based on science, it should work the same way everywhere. So you must be doing something wrong. And my father was convinced I was an idiot, and I was convinced that my father was had no idea what he was talking about. And unfortunately, he passed away a few years later, and then I came back and took over the business. And sure enough, I also faced the same problem. The exact same material, when we supply to two different foundries, performs differently. And why was that? And to understand that better, I started looking into what we were producing and how it was work. And I realized I had no idea about why the product works or how it is even supposed to work. And that was that question. So to find the answer to the question, why is it that product works differently in different foundry, led us into a path of research for over more than 2 decades now. And during the course of research, we learned a lot about green sand and how each raw material works towards it. And our first product was called NanoCarb. It's a patented nanotechnology based product that specializes in forming a barrier between the metal and the sand. Now, even with nanocarb, we realized that yes, there was a lot of benefit to the foundries, but the rejections were still there. There was still something about green sand that we didn't understand more than just creating a barrier. And that is what led us to further research and to trying to understand how the bentonite and the water works in foundries. So now, if you look at green sand, it's fairly simple. You have silica, which is the main refractory material. You have bentonite, which is the binder. Everything to do with strength comes from bentonite. And you add some water to activate the bentonite. And without water, bentonite is useless. So water is very critical. And then you add a carbonaceous additive to form a barrier between the molten metal and the sand. They're just these four components that make up green sand. How difficult should it be to optimize it, right? But unfortunately, that's a very complex reaction or very complex interaction between these materials, especially when you take into picture that you're pouring molten metal more than 1300 degrees, then it changes the entire dynamics of this. So we wanted to understand more of what is actually happening here. And what are the problems that most of the foundries face because of these interactions? So, biggest challenge that most foundries face is inconsistent moisture. Not because they're doing something wrong with the process, but the inherent nature of making castings itself brings with it this variability. You make castings of different size, different sand to metal ratio, with cores, without cores, with bigger cores, and all of this makes changes the moisture percentage in the return sand, leading to unpredictable outcomes. And most foundries have invested heavily in making sure that the return sand temperature is maintained, the moisture in the return sand is still consistent. And in spite of that, we don't see consistent results in the castings that we make. And then there's the temperature dynamics, fluctuations throughout the day, week, based on the size of castings and the core dilution. And this impacts, excuse me, impacts the mold strength and casting quality. So ultimately, all of this results in rejections like sand erosion, explosive penetration, blowholes, and more, and also results in rough castings on the surface. Now, to avoid that, most foundries are looking at more expensive options where they switch over to a better quality bentonite that's probably imported, or as a quick fix, they add dextrin to get instant strength and make sure that the castings come out okay. But any solution that is right now aimed at it is driving up operational costs, but also it is driving up the cost without consistent results. So we look at the bentonite and water interaction. So I'd like to call that a delicate dance because more water is also a problem, less water is also a problem. And the activation of bentonite has to be just right. So if you look at the fundamental role of bentonite, it's only that of a binder. Its job is to provide all the strength related parameters and make sure that the sand is good, has a good flowability so that you can make molds of it. And the biggest challenge is activating this bentonite. Bentonite understands only time and moisture. Bentonite understands how much water it has and how much time it gets to spend with that water so that it can get activated. So inconsistencies in this result in molding flaws. And there's a bigger problem of inefficient water utilization. It's not that all the water that we add into green sand is absorbed by the bentonite and it is utilized for bentonite activation. There's water that is free, that is not utilized by the bentonite, and we call it free moisture in the foundries. And this can give rise to defects like blowholes or explosive penetration and rough casting defects. But at the same time, if we add less water, then you have all these strength related issues where you have the molds breaking, where you have sand erosion, where you have scabbing defects. And the impact of fluctuating return sand temperatures and the return sand moisture just adds to this complexity. And as I told you, there are the expensive solutions that most foundries go for, but still the results are not very patchy. And there's a need for a big breakthrough here. There's a need for us to address the bentonite water interaction, and it's absolutely crucial in enhancing the quality and efficiency and effectiveness of a foundry. Now, if we have to understand this better, first we'll have to look at what bentonite is. Right? Everybody knows basically what bentonite is. It's a mineral, and the specialty of that is it gets activated when there is water. And when the water is gone, the bentonite loses its ability to perform. But this is reversible. So you add water again, bentonite gains its ability to act as a binder. But this happens only at below a particular temperature. When the temperature goes beyond 400, 500, 600, depending on the quality of bentonite that you have, there is a there's a loss of hydroxyl groups from the internal structure of the bentonite. And when this happens, the bentonite becomes deadly or it loses its durability above this temperature. And this much everybody generally understands in the foundry industry. Now, if we actually have to solve the bentonite water interaction issue, we will have to dig a little deeper to it. So let's understand the structure of bentonite and the bentonite water mechanism. So bentonite has a layered TOT structure. So it has an octahedral alumina sandwiched between a tetrahedral silica. Now, because of this layered structure, it gives rise to isomorphous substitution, which results in a net negative charge on the bentonite layer, on the TOT layer. For it to be stable in nature, this negative layer is set off by cations, usually sodium or calcium, and it is loosely attached between these layers to offset the negative charge, and that way bentonite is stable. Now, when we add water, these cations hydrate, they absorb water, and they push apart the layers and swell. That is what the swelling happens. And the hydroxyl group in the TOT layer with the water forms a hydrogen bond that creates a networked structure. Now, this is the very basic understanding of how the bentonite water works. Now, let us dig a little deeper into this. So, what actually causes the binding? So when I said that the cations like sodium or calcium, they get hydrated, they absorb water, and water being a polar molecule, it causes swelling. So if you just look at this image there, which has sodium ion, it briefly or very basically depicts how it interacts with water. Water is a strongly polar solvent, which means that it has both a negative and a positive charge. What happens is that the negative charge of the water molecule gets attached to the positive charge of the cation, in the example, sodium. And this creates a hydration shell, a shell of water around the cations. And this is what creates that swelling. Right. Now, as this swells, the individual platelets of bentonite disperse, and along with the hydrogen bond, it creates a matrix-like structure which entraps other particles, in our case, sand, and in a mechanical binding effect. Now, any water that is not bound to this cation is a free moisture. And the most important force in this is the ion dipole force. That is, the cations, uh, the force with which the cation and the polar molecule, in our case water, are held together. So, a stronger ion dipole force, the bigger the hydration cell. So, this is the basic chemistry of it. Now, why does it take time for bentonite to get activated? So now for bentonite to get activated, we need water. So there is a diffusion process where water moves from a higher concentration to a lower concentration. And this takes time. It is not instantaneous. But after that, there is another step that most of us are not aware, and it is the osmotic swelling. Once the water starts penetrating into these interlayer spaces, it causes a difference in the ion concentration inside and outside the TOT layers. And this leads to an osmotic swelling. Now, achieving this osmotic equilibrium takes a lot of time, and this is the rate limiting step for swelling of bentonite. And then finally, there's also particle distribution about or dispersion, about how good the bentonite is actually dispersed. So usually the dispersion is slow when the bentonite has been compacted or if it's been stored for an extended period of time, and which usually is the case in green sand foundries. So all these reasons add together and it results in the bentonite taking time to get activated, even if all the conditions are right. Now, what we have done or what we've tried to and succeeded is to create a strong ion dipole force at a molecular level between the water and the bentonite. And by doing this, what we have made sure is that the cat ions, either calcium or sodium, the hydration is better and the hydration shell of these cations increases. And because of this, it achieves an osmotic equilibrium much faster, which results in improved dispersion, improved swelling behavior, a much pronounced gel formation, and a quicker gel formation. And because of the strong ion dipole force, it also means that we will have to add more energy if we have to break that bond. So if we have to remove water from bentonite, we have to first break the ion dipole force, and then only water is free. So by enhancing the ion dipole force, excuse me, we have made sure that the retention of water is also much higher. Now we have to note that there's an upper limit to how much a bentonite can swell based on where it's mined from and the structure that it has. So it's not that if we can keep on increasing the ion dipole force and it's going to swell much lower. There's a limit to it. Once the layers are fully separated and dispersed, any additional force won't necessarily cause any further swelling to this. Right? So that is what we have done. So we have developed a product called MoldMax. It's a patent pending product. And what we have done is at a molecular level, we have made sure that we enhance the interaction between bentonite and water by enforcing or making a stronger ion dipole bond. And this results in a more harmonized and efficient activated process. Now, by ensuring a more uniform interaction with water, the bentonite's potential is unlocked. So, which means that the performance of bentonite is always going to be consistent and always going to be at its peak. And this also creates a barrier to most of the common problems faced by foundries. This acts as a protective layer. For example, even if there is a little less water, the stronger ion dipole force makes sure that the strength is still good. And even if you add a little more excess water, because of a stronger ion dipole force, it increases the hydration shell and absorbs the water and limits the free moisture. And So yeah, unlike traditional methods where you have a sand cooler and you have a hopper where you just don't use the sand immediately and add water to the return sand, all of these are very crucial, but it still gives a patchy activation. But with Mold Max, we have made sure that the activation is consistent and it's always. And at the end of the day, as we said, our objective is to make products that improve the ability of a foundry to be more sustainable and more environmentally friendly. Molmax reduces the need for additional additives or a higher grade bentonite, which means that there are fewer resources used, and it reduces the environmental impact and reduces the carbon footprint of the foundry. So now, okay, this sounds good or technically slightly convincing, hopefully, but how do we test this in a lab? So I'll show you a small video of what we have done and how you can test it in your labs to see what if I'm saying is right or wrong. So all foundries have this inward quality test. They check for the gelling time of bentonite. So at first, what we'll do is we'll check the gelling time of some bentonite sample that I had in my lab. What we do is we take a 10 ml of distilled water and
Vijay, you've been muted by mistake. Sorry, you're still muted.
Sir, you need to unmute yourself, sir.
Yeah, yeah. Yeah,
okay. So I'll start from this slide again. Is that okay? Or should I go back
please,
further?
please, please. You can start from here. Yeah.
Yeah. So to show you the effects of mold max on these um, the effect of mold max, how we can test it in the lab. So most foundries do have this inward tests for bentonite where they check the gelling time of it. So you take 2 grams of dried bentonite and 10 ml of distilled water in a test tube and you shake it vigorously. And the time required for the bentonite to gel is your gelling time. So we usually add some water first and then the bentonite and the balanced water. Otherwise, if you add bentonite first, then it doesn't let the water go all the way to the bottom and the gelling is incomplete. And then you add this water and then you shake it rigorously. You'll know that the gelling is complete when you stop hearing the sound of the water. Yeah. So with this grade of bentonite, it took 22 seconds to form a gel with regular demineralized water. Now we will repeat the same with mold max treated water. So for 1 liter of water, you need to add just 5 ml of mold max. That is 0.5% mold max is required for treating your water. And then we repeat the same thing. We take about 5 ml of it, add 2 grams of dried bentonite and balance of the mold max treated water. And then you shake it vigorously. And you see that it has formed a gel in just 15 seconds, which means that the gelling time of bentonite was reduced by 32% for the bentonite sample that we had in our lab. So the activation and the gelling of bentonite is instantaneous. And you can check this in your labs too. We have sent the samples to quite a few foundries where the gelling time was probably 2 minutes for regular bentonite and distilled water, but it's come down to probably 50 seconds. Or some places where they have 45 seconds gelling time, it was reduced to just 15 seconds with mold max treated water. So now, what does this mean if you actually use it in your foundry? So what are the benefits that you can see of the sand mixer? So by using mold max treated water, you make sure that the dispersion of bentonite is more uniform in the sand. You make sure that the hydration of bentonite is at a maximum. And you achieve this in lesser mixing time. So, and you also ensure that the moisture utilization is more efficient and the demand for water comes down and it eliminates the free moisture in your sand system. This better activation of bentonite results in a reduced consumption of bentonite. We have customers who have reported reduction from 20 to 40% of the bentonite by adding mold max into the systems. Now, how will the properties of the sand system change by adding mold max? So for one, you will get a higher compactability even with reduced moisture. And this is more pronounced in sodium bentonite because of the inherent nature of sodium bentonite to swell more. And because of this, you have higher strength values, even with reduced bentonite and water. You have lower friability, which means that the bentonite activated with mold max water has an ability to withstand higher temperature and higher stress, which are common in a foundry setting. And this also something that you need to be aware of is that if you're using sodium bentonite and when you add mold max, in the first you will see that the permeability decreases. That is because the bentonite swells more and this swelling reduces the ability of air to pass through it. And this will normalize once you reduce the bentonite dosage. And if you're using calcium bentonite, then you will not find this change in permeability. The other most interesting part is that there is higher moisture retention and increased GCS even after extended periods of time of say if you make the sand and even after 45 minutes, you will see that the moisture retention is much higher than conventional water and the GCS would have increased. So this means that even if for some reason there's a breakdown in your plant and you'll have to delay your pouring by 10-15 minutes, mold max treated water is able to handle that delay and you will still ensure that you have the best quality castings that are coming out of it. Now, what changes can you expect to see at the molding station because of this? Right, the sand is better flowing, so which means that the mold filling is more complete, more even. You will see improved mold hardness and consistency. You will have lesser mold breakages. You will have lesser edge and card disintegrations. You will have sharper letters and numbers, and the sand is simply more resistant to drying. Now, what does this mean at the pouring station? So at the pouring station, you will see that if you have spurting because of free moisture, that will get completely eliminated. We have customers reporting a drastic reduction in metal leak caused because of the lack of strength and especially in plaskless lines. The mold dilation and mold stability are common problems found in the foundry where you want to make a 100 kg casting, but the casting somehow weighs 101 kgs when you take it out. And this is because of the mold dilation and the instability caused by poor bentonite performance. That will get completely eliminated because of this. And you will have a better peel off at the shakeout because you're optimizing your bentonite and moisture dosage. The sand sticking at the shakeout is only because of the bentonite getting reactivated because of the free moisture in the system. So when you pour molten metal, the water moves from the molten metal and sand interface towards the back of the mold and then it condenses. And then when it condenses that, it reactivates the bentonite and that is the reason why you have these big lumps of it. So with this, we're going to make sure that the bentonite and moisture is much more intact and the peel off is better. And the effect of the castings. All of your problems related with bentonite activation, strength activation, or moisture problems will get eliminated. Your rough surface because of high moisture is reduced. Explosive penetration that happens only because of high moisture is eliminated. Metal penetration reduces, scabbing defects reduce, sand erosion, sand inclusion defects, blowholes or pinhole defects by free moisture reduces. There's an improved surface finish. Overall, you will see that all facets of the casting surface finish and the rejections are addressed because of this. So basically what we have done is we have perfected the delicate dance between bentonite and water from the molecular level. MoldMax is not just another additive. It's a groundbreaking formula engineered to enhance green sand properties. And this creates efficiency at its best. No matter what quality of bentonite you're using or what foundry processes or systems you have in place, MoldMax ensures that the bentonite water interaction is always optimized, ensuring maximum strength and mold integrity. Um, Yeah, thank you. So this automatically makes it extremely cost effective. So you don't have to use more expensive grades of bentonite. You don't have to rely on other additives. And even the bentonite that you're currently using, the consumption of it comes down significantly. So it's extremely cost effective even from the direct material point of view, but the benefits that you get in consistent castings and consistent results of the castings far outweigh the cost of mold max. And it's very simple to use. It seamlessly integrates into your foundry operations without the need for any extensive process alterations. All you have to do is add 0.5 mold max, 0.5% of mold max into your water tank that feeds your sand cooler and mixer, and that's all that you have to do. And the performance is consistent. You will achieve uniform sand properties irrespective of the fluctuations in the return sand and the temperature of the return sand. And at the end of the day, this is an extremely sustainable solution because you're making sure that you ensure or you reduce your foundry footprint. Yeah, so as I was telling you, this is how you use it. You just add about 0.5 liters of mold max for every 1,000 liters of water. Just use mold max treated water instead of your regular water in the sand mixing process and sand cooler. And you monitor your regular parameters like your compactability, moisture, GCS, WTS, permeability, and that's all you have to do. And you will see the improvement in the sand properties in the first few batches of usage. You don't have to wait for a few days, you don't have to wait for a month. The results are instantaneous with this. So I would like to share a case study about whatever I just said. So there's this foundry that melts about 7,000 tons per month. They have two high pressure molding lines in the same sand plant. And they wanted to test it in the lab first. So again, as I told you, we made a 0.5% solution of mold max treated water, and we compared it with samples of bentonite with just regular water. And we found that the gelling time reduced by about 67%. That's a phenomenal reduction in the gelling time. And we found that it increased the swelling of bentonite by about 12.5%, both in 2 hours and in 24-hour tests. We also found that the GCS increased by about 21.4% with a 4.5% reduction in water. There was no changes to the viscosity of the mold max treated water. There's no change in the pH of the mold max treated water. And mold max treated water retention was about 77% even at 120 degrees after 30 minutes. So which is a testament to its ability to retain water even in case of higher temperatures. And this is primarily because of the stronger ion dipole force. So then they decided to use this in the plant. So they have a 1.2 lakh liter tank and they added 600 liters of mold max into the tank. We reduced the moisture to mixer by about 5%. The compactability was still being maintained, so which means that you get a higher compactability even with reduced moisture. We reduced the mixing time by 10 seconds. And when doing all of this, the GCS and GSS still increased by 11%. They were using a premix, which has 70% bentonite and 30% coal dust. And then they were adding some more coal dust on the side. So we were able to reduce some more bentonite on the side. And we were able to reduce the bentonite by 13% and the coal dust on the premix by about 15%. And by doing all of this, the mold hardness improved and the consistency of the sand, quality of the sand improved. And financially, this is how it looks. They make about 450 batches per day. One mixer batch size is 4.2 tons. The moisture in the sand is 3%. So the water used per batch is about 126 liters. So the mold max required for 126 liters is just 0.63 liters. And the cost of mold max for this 0.63 liters is just 94.5 rupees. Now, in terms of the material benefits that they saw a bentonite reduction of 3 kgs and a premix reduction of 4 kgs. And with the cost of 6 and 36 rupees respectively, they saved about 162 rupees in direct raw materials. So now taking the cost of mold max out of this, you still save 67.5 rupees per batch. And with 450 batches per day, that's 30,000 saving per day. And that's a net saving of about 7.9 lakhs per month. And this is just the raw material. If you look at the castings, there were drastic improvements in the plant and in the castings. They had big spurting problems. The spurting reduced drastically. They had a huge scabbing issue, and they were using these scabbing nails. And in spite of that, they're still getting the scabbing. With mold max treated water, the scabbing was eliminated. They had a sand erosion and sand inclusion defects, which the sand inclusion used to come out when started machining these castings. That was drastically reduced. The surface finishes improved much, much, much better. And this is how the castings looked. So this is a solution not just for one aspect of the foundry. This is a solution that addresses all aspects of the foundry process where green sand is involved and ultimately the castings. So you have enhanced green sand properties because of this. You have reduced rejections because of this. It is extremely cost effective. Simplified operations, you experience smoother shakeouts, you don't have to, your post casting processes are reduced and you save a lot of time and money. Sustainable, and best of all, you have consistent sand parameters. No matter how, what castings you're making the previous day, or no matter what other fluctuations you have in the foundry, the sand parameters are always going to be consistent with this. So this is an innovative solution. Like I said, this is we just don't offer bentonite. We address the core issue of the interaction of bentonite with water at a molecular level. So we really don't care what bentonite grade you're using. No matter what you're using, you will still find this similar results and more effective results at your foundry. Cost effective and consistency is, I think, what every foundry is looking for. And of course, you get the unparalleled support of our team that is ready to guide and assist you if you want to try out more Max. Now, before I open this up for questions, I would like to invite Dr. Senthil Kumar of Blue Mount Castings, Coimbatore. He has been early adapter of technology and been very supportive. He was very interested when we came up with this technology and he decided to use it in his foundry. So, Dr. Senthil Kumar, I would like to invite you to share your experience with MoldMax with our colleagues here.
Yeah. Good evening, Chairman, Chennai chapter, and good evening, Vijay. I've been using this mold max for close about 15 days, as guided by Vijay. And on the first day itself, we could see very good results. The peel off was better, and the casting shine after shot blasting was very nice. And I wasn't convinced. Over a week, we checked the castings, continuously adding mold max. Right now, when on the last Thursday, I believe I checked personally all the castings. It is too good. It's very nice. The problems we had with the castings earlier was the cope portion was having a better finish and the drag portion was having a slightly lower finish. All these problems got settled, and particularly when you check with the lab results, our dead clay was gradually increasing and we were struggling to control the dead clay. As we used the mold max for more than 10-12 days, we had to reduce our bentonite because the strength was very good and the compactability was going very high. So we had to reduce the addition of bentonite, and as such we reduced. And right now we see a huge reduction in dead clay. It is around 1.4% we reduced in around 10-12 days of working with mold max. We had checked more than 450 castings we machined, and there was not even one single casting which had a blowhole defect or any other defect. In the floor level, the defects what we got was only because of our tooling and our operator mistakes, and not because of sand related any other defects. Sand related defects have completely disappeared, and we find that this product is very helpful. This what is my honest feedback. I've been interacting with Vijay, and Vijay told that the permeability will slightly reduce. And this is an information for you, Vijay. I took yesterday's reading and today's reading also. As we started reducing the bentonite now for the same strength, the permeability has increased by 30 points.
Wonderful, wonderful, sir.
30.
Thank you so much for this information.
It has increased. So there is a possibility that the gases have started escaping better. So the castings would be much better better, and the risk is not there. I was actually getting very much worried last month, and somehow we got interacted, and right now most of the problems what we faced, even the you had told about the spurting and the scabbing, we also had that, and those have completely disappeared. The casting looks really pleasing, and the entire surface there was a different, when there is a thicker section it would have a different surface finish, thinner section will be having a better surface finish. All these things are completely gone. It's almost like a shell molded casting. Everywhere it is having the same surface finish, and we are happy about using your product. Thank you very
Yes, sir.
much, Vijay.
Thank you, sir. So one more question. Did you also see a reduction in your bentonite consumption, sir?
Yes, of course. From 0.6, 0.7% addition, it is right now 0.38 to 0.4 only.
Wonderful, sir.
Point
Wonderful.
3, yeah, it has reduced, sir. That's what I told you. The deadly also got reduced because of the reduction in bentonite. The sand is freely flowing, sir. The packing, I personally checked the molds and all. The packing is very uniform in the molds, and there is no sticking of sand in the belt or in the knockout. And we also find that there will be sticking of sand. Some sand will be sticking in the shakeout, and it will be normally it will be going out. That problem is also eliminated. So sand is also getting saved. So my additives, new sand is very low right now. Very low addition we are doing, and bentonite has also reduced. We also reduced our lustrous carbon additive. So overall, there is a total change in the sand system. I wish other foundries also follow this with Mold Max, and I believe they will also find a large difference. Within 2 days itself, you can see the castings with much better shine, sir. It is shining, sir. I have never seen such shine. It will be normally dull finish, but that shine itself is what the picture you have shown in the presentation. That shine has come.
Wonderful, sir.
So yes, it is really a good product, and I wish to appreciate you for finding a proper solution. And thank you very much. And I'm going to give you another challenge. Since the molds are good, we want the cores also to be good. So you have to give us a solution for the core also.
Wonderful. We are working on that, so we will definitely hope to satisfy all the needs. And thank you so much
Yes,
for
sir.
your honest feedback. And now I would like to open up for question and answers and see if I can answer any questions that you might have. Thank you, sir. Thank you, Doctor.
Thank
Yes.
you, Senthil sir. And Vijay, there are 3 questions already in the chat box. One from Mr. Jagadish. He has asked, does the performance depend on metal being cast?
No, it does not depend on the metal being cast. It is independent of the chemistry of the metal. This is only to make sure that your bentonite and water interaction is more complete. And all the benefits that you see is because of a more complete and comprehensive interaction of bentonite with water. It is independent of the metal that you see, that you cast.
And then there is a question from Mr. Venkatakrishnan, Madras Engineering. What about gas defect after using this method?
So it depends on where the gas is coming from. If the gas is coming out of the water that's evaporated, then that gets eliminated completely. And if the gas is coming out either of your coal dust or something else, then this does not play a role in it. And probably it might help because as Dr. Sendil Kumar just pointed out that their permeability increased for the same AFS number because your bentonite consumption also reduces. So that might help in reducing gas defects, but it will eliminate the gas defects that arise out of moisture in the green sand.
Right. Then there is a question. I don't know who it is. It says unknown. Are you going to share the presentation? Sir, I would like to mention that Chennai chapter has a YouTube channel. We'll be uploading this entire conversation with the presentation on the YouTube channel. So you can refer that is what I would say. And Mr. Srinivasa R, he has asked for cost impact.
Yes.
What is the
So
cost
like
impact?
I had shared on the presentation a case study with significant cost impact. So the cost impact, the two parts to it. One is the direct cost, and the other is also a direct cost, but more intangible because it's about your surface finish and your improved efficiency and your reduced rejections. You will definitely see a huge cost impact, and you will see a lot of savings once you produce castings which are better and also at a lesser cost. Yes, you'll save costs in the direct materials itself.
Okay. And then there is a question from Mr. Kandan of Breaks India. Is there
Mhm.
any impact on WTS and any change in TDS of water?
No, there absolutely no change in any of your water properties. This your properties of water simply do not change. And yes, there is an impact on the WTS in the sense that even for a lesser bentonite dosage, you will find a similar WTS as what you're getting now. So, which means to say that your WTS per kg of bentonite improves. So, all of your strength parameters, all of the parameters that you use to measure the performance of bentonite will improve. Uh, that is something that you will
Right.
see.
And next question from Mr. Arun. Uh, how it will work in a vertical parted mold?
It will work in a similar way. See, MoldMax does not know if you're using, or the bentonite does not know if you're using it in a vertical part mold or in a horizontal flaskless line. So it doesn't matter. The performance of the bentonite and the interaction of the bentonite and water is always complete. And all the benefits that you get out of it are irrespective of the kind of molding lines that you have or the type of castings that you're making. So you will definitely find similar benefits in a vertical molding line too.
Okay. And then there is a question. It says PC. Dear sir, please tell us about reduce the blowhole and pinholes. How to reduce the
Mhm.
blowhole and pinhole?
Well, it the blowhole and pinhole are basically gaseous defects. We will have to figure
Mm.
out where the gases are coming out from. So if the gases are coming out because of excess free moisture in the system, then MoldMax will definitely eliminate them. But even after using MoldMax, if you're still getting blowholes and pinholes, then you can be rest assured that's not coming out of your free moisture. And you will have to look at other parts of the green sand which gives out gases like your carbon additive or any other additives that you might be using. But most of the cases, the blowholes will come from the moisture that gets evaporated because every molecule of water, when it changes its phase from a liquid phase to a gaseous state, expands in thousands of times. And because of that, there's a huge volume difference that happens, and it's almost like an explosion inside the mold that happens. And because most of the problems are because of the excess moisture, then Mold Max will definitely take care of it. And also, you will see an improved permeability from what I understand from Dr. Sendit. And that should also reduce your blowhole and pinhole problems because if it is generated from other areas, then the permeability is better and the gases escape. So it should help.
Right. And then there is a question from Mr. Ashok.
Mhm.
How it exactly works with green sand mixing? Can you explain the mechanism to reduce bentonite and compactability?
Mhm. No, it doesn't directly work with green sand mixing. It really doesn't matter where this bentonite is being used. All Moldmax does is that it acts as a catalyst for the bentonite and water interaction. Now, the entire green sand process or the sand system is designed around this activation of bentonite taking time. When you add a catalyst to it, it makes sure that whatever you wish to achieve in probably 120 seconds of mixing, you will probably achieve it in just 80 seconds of mixing. And that's how it actually impacts. And now, most foundries have a patchy activation of bentonite, not because they're not good at it, because that's the limitation of the process that we have. So, as I was telling you, that achieving an osmotic equilibrium is very important for the bentonite to get activated completely. And in the lab, you just let it sit for 24 hours with excess water when you check the swelling. But in a real life foundry situation, that's never going to happen. You probably recirculate the same sand 5, 6 times a day, And it's impractical and also slightly illogical to expect bentonite to get activated completely naturally in that short duration of time. By adding mold max, we make sure that that activation is complete, even though the time available to achieve the equilibrium is much lesser because mold max acts as a catalyst. And once the equilibrium is achieved, once the activation of bentonite is complete, you actually don't need as much bentonite. So your strengths will start increasing, your active clay will start increasing. All the parameters that you start measuring, you will see an increase in that because your bentonite simply performs better now. Um, and automatically you reduce your dosages. And that's how you see the benefit with this.
Right. Then there is a question from Mr. Sunil. He says he's from the bentonite manufacturing side. Is it possible to add the product during bentonite activation process?
Yes, it is possible to add this product during the bentonite activation process, but the benefits of the product might be lost over transit, but it will definitely speed up your activation process. So what usually takes your a cation exchange where you exchange calciums with sodium or magnesium with sodium cations, that exchange happens much faster with mold max. But you will also, even if you use it at the manufacturing and the activation stage of bentonite manufacturing, you will still have to use it in the foundry because the activation of the foundry, you have compaction in the foundry, you have bentonite that gets stressed in the process of making a casting. So you will have to still use it in the foundry. But yes, you can get benefits of mold max for faster activation of your bentonite while activating it in the mines.
This is actually a continuation to Mr. Arun's question. He asked you how it will work in the vertical parted line. And he is further asked, since the sand ratio is less in vertical molds.
Uh, Again, so I think the lesser the sand to metal ratio is, the benefits I think are more pronounced. So if you have a lesser sand per ton of liquid metal, which means that more of the sand is exposed to a higher temperature. And that is where making sure that the moisture retention in bentonite is more essential to get a good casting. And this is going to exactly do that. So once we start increase the ion dipole force, then the amount of energy required to break that water molecule away from the cation is much, much higher. So which means that water is going to be in a liquid form for a much longer time. And as long as it's in a liquid form, you have your hydration shell intact and the bentonite is going to perform. And because of this, the energy or the heat energy that is there when you pour molten metal is also dissipated and it is utilized in breaking the ion dipole force and the water evaporating rather than burning up the hydroxyl ions of the bentonite and making them into dead clay. So it is definitely going to be more effective in a situation where the sand to metal ratio is is less, and you will find better benefits than most of the people.
Right. And the next question is from Mr. Muthuramalingam of Breaks India. Is there any chance in change in mixing cycle time? That is there any reduction of mixing time possible?
Yes, absolutely. So in the case study that I shared, they had a 120-second cycle time, and we reduced the cycle time to 110 seconds. So we reduced it by about 8%. And there was scope to reduce it further, but they said they will do it over a period of time. There's a huge scope for you to reduce your mixing time also now with this, because the reason why you're mixing it for such a long time is to make sure that the water get dispersed evenly into the layers of bentonite and the bentonite gets activated. But with mold max, because it acts as a catalyst, you definitely can reduce your mixing time too.
There is a question from Mr. Arun. What is the recommended TDS level in water?
I think there's no recommended TDS level. I think anything less than 300 ppm should be enough, should be okay for bentonite. More than the dissolved solids, it is the ions that are present in water that could create a problem. So if you have, say, more magnesium ions or magnesium salts in the water, and you use that to activate your bentonite. As I explained earlier, bentonite has these exchangeable cations. And sodium has a higher ability to create a bigger hydration shell, calcium slightly so, magnesium even lesser. So if magnesium replaces your sodium or calcium in the bentonite structure, then automatically your performance of bentonite is going to come down. So more than the TDS, it's about the salts, the different salts that you have in the water that creates a problem. But yeah, usually anything less than 300 should be fine.
Okay. Then there is a question again from PC. Sir, please tell us how many MB value in bentonite is acceptable in the system.
Again, so the methylene blue value is the methylene blue test is something that you do to measure the cation exchange capacity of the bentonite. What you're basically trying to do, excuse me, is to see how much of the cations are there in the bentonite that can be used to form a hydrating shell and that can absorb water. And that's what your active clay test and the methylene blue test does for you. So there is no standard value for it. I think the value of that depends on the quality of bentonite that you're buying. And it depends really on the grade of bentonite that you're using. There's no standard value for that as such. And it changes from mine to mine, supplier to supplier. The calcium, sodium varies a lot on that.
There is a question from Mr. SB. How to fix mixer dry wet mix time versus bentonite addition percentage, and how to focus with respect to foundry defects like scab, blow, gas defects like vertical molding line.
Okay. So I think the primary metric that you should probably fix is what's the strength that you require. So based on the strength that you require, I think you can go optimizing your bentonite and your moisture and your mixing cycles based on that. So usually dry mixing is a very important part of it because when you add a fresh bentonite into it, and as I explained, the activation of bentonite depends on how easily water disperses into it. And if all the bentonite is in just one place, then it takes a much longer time for that bentonite to get activated. So if you're able to get a good dispersion of bentonite, of the fresh bentonite that you add in the mixer, then you should probably reduce it. With MoldMax, I would recommend that you don't have any dry mixing time at all. You can probably make it to 0 and you will still have an excellent dispersion that you achieve with it. So that really depends on kind of things that you do. And also, it is not necessary that increasing your wet mixing time increases the performance of your bentonite. There's only a limit to which your wet mixing time is going to activate the bentonite. Beyond that, you're just wasting energy and you're not going to get any benefits out of it. So it's something that you'll have to figure out based on how your bentonite and the quality of your bentonite and the strengths that you require. But whatever process you use, MoldMax is definitely going to improve in all aspects.
Right. I think this is the final question. I think this is from Mr. B.S. Govind. Any comment on the effect of the pH value of the presently used water?
If it is pH plays a very significant role in the activation of bentonite. So most of the activation of bentonite is more to do with ions and the interaction of these ions with water, and pH definitely plays an important role. But a very high pH is detrimental for the activation of your bentonite also, because then there's a competition between the water molecules and the hydroxyl groups because of the increased pH, and this might rob away the water molecules from the cation and result in a depleted hydration shell. So, but as long as the pH is about less than 10, I don't think it should be a problem, and it's still going to work well. MoldMax is independent, will work independently of whatever pH that you're currently maintaining. As I said, mold max doesn't alter the pH of the water. It doesn't alter the TDS of the water. It just makes sure that the ion dipole force is much stronger in the cation polar water reaction. And that is all it does. So if you're maintaining a pH of 9, you can maintain that. We don't ask you to change any of your process parameters because it is the way mold max was is independent of all of that.
Right. Thanks for answering all the questions, Vijay. If there are any further questions, there's one more question. If sand temperature is above 55 degrees Celsius, will it work?
Yes, it will definitely work. Um, uh, I don't know if you have a sand cooler in your sand plant, and if not, then as I told you, the moment bentonite mixes with mold max treated water, the water is absorbed onto the cations, and then the force is quite strong. So if the water has to evaporate from it, it means that it has to absorb more heat from the surrounding sand to evaporate. So which one, make sure that your sand becomes cooler slightly faster than regular water. And the other, even though your sand is hot, the activation of bentonite is still complete. The hot sand is not robbing away the moisture from bentonite because of the ion dipole force. So, which means that the water that you go first goes and interacts with the ion, and then the heat of the sand has to compete with the ions to remove the water away. So, it's definitely going to help foundries where the return sand temperature is hotter.
All right.
Vice Chairman, I think all the questions are over.
Yeah.
Yeah. I think the very interesting subject. Now I request our. Can we go for a closing? Vice Chairman.
Yeah, I think if anybody else has any questions, you can unmute and ask. Or
Yeah, tell me, sir. Sir, tell me, sir.
Sir, Vignesh, sir.
Yes, sir.
Sir, சொல்லுங்க.
சார் இந்த ரெஃப்கோட் வந்து நீங்க அவர் சாரை கூப்பிட்டுட்டு இங்க பிரேக்ஸ் இந்தியா விசிட் பண்ண முடியுமா சார்?
கண்டிப்பா பண்ணலாம் சார்.
ஓ, இது நீங்க
we represent them in Tamil Nadu, sir. Yes, sir.
Yeah, Shriram Enterprises represents in Tamil Nadu. We have Technomet that is representing in Maharashtra and North Karnataka. And we have Manikanda engineers representing us in Indore and Madhya Pradesh area. So you can reach out to them or you can reach out to me and I can put you in contact with them.
Okay, sir.
Vijay, sir wants us to visit Breaks India. He's in Unit 2. So
wonderful. We'll do that.
Yes.
Gentlemen, if there are any questions? Okay, otherwise,
Sanjay, we can go for closing.
Yes, sir. I would request Council Member Siddharth to give a closing, sir.
Just based on the questions, I am pretty sure that this has been one of the very clearly articulated sessions we've had, and most interesting and valuable based on the questions so far. So it gives me immense pleasure to thank our speaker first for such a clear and crisp session. So it was so useful for everyone, and we had. I think you will be getting more questions even after the session. So be prepared, sir. So I thank IAF Chennai chapter for organizing these webinars every week, these technical sessions for ferrous and non-ferrous, and helping our members to gain more knowledge and practical information in their day-to-day work. So I once again thank our chairman, vice chairman, our secretary right now in our program, our guest speaker, and all the members who attended for this session. A big thank you for making it a really good session. Thank you.
Thank you, sir. Thank you for having me.
Thank you all. Thank you. Thank you very much.
Thank you. And thank you, Dr. Sen.
Thanks. Yeah. Thanks to everyone who joined the program. Thank you. Thanks, Vijay.
Thank you, sir. Thank you, sir.
Thank you, sir. Thank you.